Hi, so for this session we will be solving quadratic equations, which basically means we have to find the x-intercepts. So just say we've factorized a quadratic equation, we are now going to be taking the next step and to actually see what the x-intercepts are, what their values are. For example, it might be -2 and +3. And to do this, just like with linear graphs, we have to find the x-intercept for a straight line, y has to equal 0. So you notice the first step when doing this, we need to ensure the right hand side is equal to 0, okay? Or I'll put in brackets, or y. That didn't work. Or y is equal to 0. That's what we're making actually become 0. Then the next two steps involve factorizing. So sometimes the equation may not be factorized. You have to factorize it. And then step 4 says to use the null factor law. So I'll be explaining what we mean by the null factor law. It's actually quite easy, so don't stress about that. And step 5, if sometimes we end up with when we factorize something, like for example when completing the square, we sometimes end up with irrational numbers or surds, and you can leave the surd in exact form. Or if the question asks you to round it off to just say 2 decimal places, then you can do that and get an approximate answer. So we'll be going through all of these steps. So if you want to write them down, go ahead, and I'll be explaining them in detail as we go. So with our first example, question 1, we have a quadratic equation. And you can see it's a trinomial. We've got x squared minus 7x plus 12. And it hasn't been factorized. So you can see how we got y equals to all of this. Usually when practicing your factorizing skills, you don't see y equals the expression. You just have x squared minus 7x plus 12. So we just added a y here to now make it an equation, basically. And it's the same thing. So now, to solve this, our first step is, well, to make y equal 0. In this case, the y is on the left-hand side, and that's fine for now. But later on, you'll see we may put it on the other side to solve. But for now, we'll leave it there. So we have 0 equals now x squared minus 7x plus 12. Now, if you remember those steps, we've made y equal 0. Take out any common factors if we can, and if we need to factorize. So clearly we have to factorize this expression. It hasn't been factorized yet. And then once we've checked if we can take out factors, let's factorize using the applicable method. Alright, so if we have a look at this trinomial, to factorize this, can I factorize this nice and easily using what I call the fast method? Let's have a look. If I get my 2 brackets ready, let's see if I can factorize it easily. If I can't factorize it easily, then we may have to use completing the square method, if you remember doing that. But let's try and see if we can do it easily. So is there a number, are there 2 numbers to give you 12 that add to -7? So what are factors of 12? We have 3 times 4, and we have 6 times 2. But I'll stop there because I can see that 3 and 4, with these factors, it is possible for me to reach a 7. Okay, 6 plus 2 is 8, 6 minus 2 is 4. It's impossible to get to 7. But 3 and 4, I can get to 7. Now, 12 needs to be positive, okay, but 7 is negative. So straight away when I see this, I know that I have to have -3 times -4, which will give me a positive 12. And -3 and -4 will give me -7. So what goes in the brackets? We have I'll change the color. So in here we have -3 and -4. Okay, so that was pretty easy to factorize. So we didn't have to use the completing the square method or the grouping method. There was no the coefficient of x squared is 1 here, so this was nice and easy to factorize. So now we will be taking the next step, and that is now that we have factorized this, we have to solve it. Let's see what the x-intercepts actually are. Now before we continue to solve, I just want to quickly show you why we have to actually factorize, and that is, if we had an equation like this, just like the one we had before, x squared minus 7x plus 12, if we had to solve this, you can see how it is impossible to solve. Because we've got x squared, which is a different variable, to x. Even though they may look the same because they both have x, we know x squared is completely different. And we can't add x squared minus 7x together. And we're stuck with this equation and expression. And that's why factorizing enables us to break up the x squared and the x and enables us to be able to solve. So just keep in mind why we have to factorize. So let's just go back to our example. Now, we've factorized this trinomial, and now we have to apply what we call the null factor law, or null factor law. So null, I'll just write it up here quickly. And I'm going to explain what we mean by this. It's actually really easy, and basically, if, for example, if we have a times b, two different numbers, equal to 0, just say. What can a equal? Well, if I divide the b, because we know we have a times b here, so if I just quickly divide the b to get rid of it, just like solving a normal equation, and divide the b on this side, what does a end up equaling? A ends up equaling 0, okay? But what if I decided to get b on its own? So I'll write it out again, okay? Equals 0. What if the b wants to turn to be on its own? So if I divide by a, that cancels out. B can also equal 0. And that is what the null factor law states and what it's saying. It's simply saying if you have two different numbers, in this case we have a times b, and they're equal, to 0 in this case, there are two solutions. One where a can equal 0, or the second solution is where b can equal 0, because they both get a turn to be on their own. In this case, for the first one, we went, well, let's cancel the b, and we ended up with a equals 0. In the second attempt, we solved for b, divided by a, and b equals 0. And you can see we can have two solutions, not just one. And it works. So this is what the null factor law is. When we're multiplying two different numbers, okay, they can both have a chance to equal something. And in this case, they both equal 0. So we will be applying this null factor law to what we have up here, okay? So it's going to be our next step. So now we are going to apply the null factor law to figure out what the x-intercepts are. Now, what I'm going to do, I'm just going to rewrite my equation and make the 0 now and put it on the right-hand side. So if you remember your, solving equation skills, if you want to swap this, you can. Just write x minus 3. Now, I'm going to emphasize the times here, and then we have x minus 4, okay, and equals 0. I haven't changed anything, I've just rewritten it this way, and we know how to do this. Now, the reason why I've emphasized on this times is, remember, the null factor law said if we have a times b, okay, or ab, and equals 0, the solutions will be a can equal 0, or we can have b to equal 0. Now, if you have a look, in brackets here we have x minus 3. Now, remember, x minus 3, even though they look like they are two different numbers, if we knew what x was, it would actually be a number. For example, if x was just say 10, we'd have 10 minus 3, which is 7. So what we have in brackets here, think of it as one number, just like a, times a second number, which could be b. Okay, so just say that's your a and that's your b, or a times b, equals 0. Well, they both get a chance to equal 0. So to solve this, you get number a, which is now x minus 3. You can write the bracket still if you want to. That gets a chance to equal 0. But also, just like down there, also, we can have x minus 4 to equal 0. They both get a turn to equal 0. And you can see what's happened. Now, the brackets don't have to be there anymore because they're no longer together. We're solving each one separately. And now we have x minus 3 equals 0 and x minus 4 equals 0. These will be our two different solutions. And now we just solve this as we normally would. If we want to get x on its own and solve for x, well, we have to plus 3 on this side and plus 3 on that side. So x will equal positive 3. Or we can have plus 4 on this side, plus 4 on this side, and x will equal positive 4. And we're done. These two numbers, so x equals 3 and x equals 4, they are our solutions. And remember what we mean by solutions? Solutions are the x-intercepts of our parabola. So I'll just draw a quick sketch of a parabola to show you what I mean. So when we come to the chapter, when we start drawing parabolas, this is what we'll be doing. And that is, if our parabola, some parabolas can have two x-intercepts, and we can see clearly this quadratic equation that we factorized and we found the solutions clearly has two different x-intercepts. One where x is positive 3, so imagine I just put positive 3 here, and one where x is positive 4, and I'll just put it there. Okay, excuse the inaccurate scale. Now, if these are our two x-intercepts, they're 2 points of our parabola, and our parabola will be passing through these 2 points just like that. Okay, now there are other features of the parabola we have to learn to find as well, which we have sort of already. That is the turning point and also a y-intercept. And if we have these important points, we can pretty much sketch and draw an accurate parabola without any problems. They're the points we have to find. But at this stage, we have found these 2 points. When x is 3, that's one x-intercept, and when x is 4, that is another x-intercept. Okay, so hopefully you have a better understanding of why we factorize, and then why we have to solve what we have factorized. Let's try a few more questions. Okay, so for our next two examples, the question is asking us to find the solutions or to solve. So with the first one, you can see both questions have been factorized for us. So a step's been taken out. That's nice and easy. And you can actually see what the solution will be. It's basically the opposite of what you see in the bracket. So if you've got x plus 5, the solution's going to be x equals negative 5. And we've got x minus 2 in here, so the solution will be x plus 2. And to show working out, well, using the Nonfactor law, we make both of these equal 0. So x plus 5 will equal 0. And we also have x minus 2 to equal 0. We minus 5 on both sides, so x will equal minus 5. And x will equal positive 2. And they are our two x-intercepts our parabola will be passing through. And we're done. With question 2, you notice there's a 3 out here. Now, what you can do is you can do this, because this 3 is saying it's being multiplied with the, this bracket here, but also this one here, because they're all joined by multiplication. So what you can do is, if you want to take them out separately, you can do it this way, and that is you have 3 bracket x minus 2 to equal 0, or we have 3 bracket x plus 6 to equal 0. And then if you expand the brackets and solve, you will get your answer. But a faster way to do this, I'm not going to do it this way. I'm just pointing out, if you did do it this way, if it makes sense to you, you'll get the same answer. But the way I'm going to show you is this. What you can do is simply divide the 3 and get rid of it. There's a 3 times here. So the first step is, let's get rid of this 3. Divided by 3, divided by 3. 0 divided by 3 is just going to give us 0. And so we end up with, I won't put an equal sign there, we end up with x minus 2 and x plus 6 equals 0. The 3 is now gone. Now get each one of these to equal 0, and you can see that x is going to end up equaling positive 2 and here negative 6. So let's just show some working out. So x minus 2 equals 0 for this one, or we can have x plus 6 to equal 0. Solve each one. X will equal negative 2, and here x will equal positive 2, and here x will equal negative 6. And they are the 2 points where the parabola passes through the x-axis. And like I said, if you did it the other way, you would have still gotten these two solutions. Okay, so for our next question, once again, we will make each one separately equal 0, because we know using the Nonfactor law, because there's a times there, each one gets a turn to equal to 0. So we can have 2x plus 1 to equal 0. Or we can have, I'll just do it down here, 5x plus 2 to equal 0. let's solve each one separately and see what our x-intercepts will be. So to solve this one, we can see the 1 will go first. So -1 on this side, -1 on that side. That cancels out. And we have 2x equals -1. Final step is to divide by 2. Divide by 2. This cancels out. So x will equal -1/2 or 0.5. That's one x-intercept. Next, down here, to solve this one, we have +2, so the opposite is to -2 on both sides. This cancels out, so we have now 5x equals -2, divide by 5, and divide by 5. This will cancel out, and so x will equal -2/5. So once again, we have another decimal. And these are the two x-intercepts our parabola will be passing through, or our two solutions. So our next two questions, we have to, once again, we are still trying to find the solutions or to solve the equations. Now, if you notice with question 4 and 5, as soon as you see an x squared, okay, you can tell that the quadratic equation has not been factorized. And so we have to somehow factorize it. Now, with question 4, these types of quadratic equations are the easiest ones to factorize. And for some reason, students don't see it. They can't see how, and they leave it blank or get it wrong. Have a look. We've got x squared here minus 3x. There is no constant. Okay, this all equals 0 because y is 0. To factorize x squared minus 3x, all you have to do for this one is take out an x as a factor. So if I take out x as a factor, in the brackets, I will have, well, take away x from there. We've got 1x left here. Take away an x from there. We end up with this. Okay, and we have factorized it. I'll just rub off this question and we'll do it again later. And you can see how easy that was to factorize. So keep in mind, whenever you see a quadratic equation where you go to x squared and just say, in this case, plus a number, let's say 7x, and no constant, no number on its own, whenever you see these types of quadratic equations, remember, they are the easiest to factorize. Just take out the x. All right, let's continue. So, now with this one, see how we've got an x sitting on the outside? Don't let that confuse you, because what's happening is, if I wrote this way, x, just say plus 0, bracket, x minus 3 equals 0, that's exactly the same thing, x plus 0. That's why the x is just sitting here now by itself. Imagine we had x plus 0. Each one, you still get to equal 0. So this x here gets to equal 0 straight away. And that's one x-intercept. The other one, we have x minus 3 equals 0. And plus 3 on both sides, plus 3. So x will equal positive 3. So there's one x-intercept. There is the other one. Okay? And if this is still confusing you, I'll quickly sketch what our parabola will look like. So if our x-intercept is 0, it's passing through the origin, and the other one is when x is positive 3. If we were to quickly draw our parabola, okay, it'll look like something like this. That's it. It's passing through the origin because the x-intercept is 0, and passing through this point here too, where x is 3. And that's it. So whenever you see an x sitting on the end of a bracket like this, remember it's really saying x plus 0, or to do it fast, x is just going to equal 0 for one of the solutions, and then your next solution, you just solve it the way we did. Now, our next equation, so once again, we have to solve this. Now, how do we, so we've got x squared minus 9, okay, and y is 0. Now, to factorize x squared minus 9, we can't take out an x as a factor, and we somehow have to factorize this to get rid of this x squared. And remember what this looks like? To factorize this, we have a squared minus b squared. And all we're going to do is rewrite the 9. Because it's a perfect square, we can have this, x squared minus 3 squared. Okay, this can equal 0. And now, we're using our knowledge of the difference of perfect squares. So we have a plus b and a minus b. That's what it will equal. We just have to chuck this in brackets. So remember, this is x is your a. If it helps, put brackets around the x to emphasize that. And b is your 3. We have a negative, so it is possible to factorize. So we have this, a squared minus, oh, sorry, what am I doing? A plus b, so x in one bracket plus b, which is 3, and then x minus 3 equals 0. And now what we have to do is to solve this. Okay, take the next step. Once it's been factorized, we can see what the x-intercepts will be. If we make each one equal to 0, we will end up with, just like before, opposite of x plus 3, we'll end up with x is equal to minus 3. And on this side, we will end up with x is equal to positive 3. And these will be our two x-intercepts. And we're done. Okay, so I didn't show the working out on how I solve this because we know how to use the null factor law now, and you can skip the working out part because you can actually see if it's x plus 3 and we solve it, we'll end up with minus 3. And if we've got minus 3 here, we ended up with positive 3. Now our last question for this session is this one here. We've already made y equals 0, and I've put the 0 on this side already, so it's one step done. Okay, now to factorize this one, we have a trinomial. So whenever we see trinomials, I guess they're the hardest ones to factorize, and they, I guess, can be annoying. Now, let's see if we can factorize this nice and quickly. Let's just try. Maybe we can do it quickly. Get our brackets ready. We've got x squared, so x times x. The coefficient of x squared is 1, so that's an easier step. And now, something times something to give me 2, that can add to negative 4. Well, the only thing that can give me 2 if I multiply is 1 times 2 or 2 times 1. And unfortunately, there is no way 1 and 2 can ever get to 4. If we add 1 and 2, we get a 3, so it's impossible. So unfortunately, we've got to cancel this way. We have to now complete the square. So if you remember how to complete the square, we have to use this method to now factorize this and to find our x-intercepts. And with completing the square, just remember we can also see the turning point form, and we'll also be using this to find the turning point later on of our parabolas. So now to complete the square, we have to halve b and square it. So b is equal to negative 4. Even if you forgot about a negative, it wouldn't make a difference because it'll always be positive because we're squaring it. So halve b and square the whole thing. So negative 4 divided by 2 is negative 2, and negative 2 squared is positive 4. And there we have it. So now that we have halved b and squared it, we've got 4. We now have to add it in and then subtract it. So let's do that. So we've got x squared minus 4x. Half of b and squared, we know it was 4. So we add the 4 here. Always add first, but then we have to subtract it. Okay, to keep the equation balanced, and don't forget the plus 2. So I've in that reddish color, you can see what I've added in and also subtracted by halving b and then squaring it. Now our next step, and this is all equal to 0. I'll just squeeze it in there. Now our next step is to complete the square. We group the first 3 terms, and this will give us a perfect square because we halved b and squared it. This will easily be factorized into. Get your brackets ready, squared on the outside. So I want you to automatically do this when completing the square. Your x goes here. Because we have a negative here, we end up with a negative in there. Okay, and what's half of b? Half of b is 4. Is 2. So we put a 2 in there. And done. We factorize this part here. So when completing the square, you always end up with something like this, a perfect square. And now, we have minus 4 plus 2. Well, minus 4 plus 2 leaves us with negative 2. And this all equals 0. And at this stage here, I'm going to always emphasize this. At this point here, we have the quadratic equation in turning point form. And I can see what our turning point will be by looking at this. And we'll learn how to do this later on. But I want you to identify that this is the turning point form. Now, we have to continue factorizing this to find what the x-intercepts are by solving. So now, remember, this is in the form of a squared minus, we have a minus here, so it's possible, b squared. So if x minus 2 is our a, our b, unfortunately here, it's not squared yet. And we can see that we have to add in a square root, okay, and then, of course, square it to make it a b squared. And so the square root of 2 is our b. And now we put it in brackets. So we end up with a plus b and a minus b. Okay, so let's see. We have a is x minus 2 in one bracket. So x minus 2 plus b. So plus b, which is the square root of 2, close bracket. In the next bracket, we have a again, so x minus 2, but this time minus b, so minus the square root of 2. And all of this is equal to 0 because y is 0. Now that we have factorized it, we now have to solve this to see what our x-intercepts are. So now to solve this, using the null factor law, we make each one equal to 0, each bracket equal to 0. So the first one we have, and we don't need the brackets anymore, and it's just frozen, so sorry about that. Okay, so we've got x minus 2 plus the square root of 2 equals 0. That's going to give us one x-intercept. The other one will be x minus 2, instead of plus now, minus the square root of 2 to equal 0. So now let's solve each one. So here we end up with, basically to solve this, x has to equal everything. So the minus 2 has to go on this side, and the plus square root of 2, which is a third, has to go on that side too. So the opposite of minus 2 is to plus 2 on this side. Opposite of plus the square root of 2 is to minus the square root of 2. So minus square root of 2. So for this one, x will equal a positive 2 minus the square root of 2. This one down here, we have to they're both negative, so now we have to plus 2 on both sides, and also plus the square root of 2 on both sides. And they look very similar, but you can see this one has a negative here, and this one has a plus. So x will equal 2, instead of take away, plus the square root of 2. Now, if the question didn't ask you to find an approximate answer, you can stop here. This is what we call an exact solution, or an exact answer. Because we have a surd, we know surds, like the square root of 2, are irrational, which means the decimals go on forever and ever and ever and never end and have no pattern. So if we were to put this in the calculator, it will give us an approximate answer, okay? And when you have a question like this, they will usually ask you to round off to 1 decimal place or 2 decimal places. So read the questions carefully. And if you had to draw this, then of course you have to put it in your calculator to get an approximate answer, because you have to know what the decimal roughly is. So let's put this in our calculator to see our approximate answer. So to get an approximate answer, just use your calculator. So push in 2 plus the square root of 2, and this should give you, if you round it off to 2 decimal places, so now that we're getting an approximate answer, instead of equals, I'll put the approximate symbol, which is a squiggly equal sign, and 2 plus the square root of 2 approximately equals to 2 decimal places 3.41. And for this one down here, x will approximately equal 2 minus the square root of 2. Now the square root of 2 is 1.414 and so on. So it's going to give us approximately 0.59. Okay? And once again, these approximately show us where our x-intercepts will be if we were to draw our parabola. X is positive, so if I did 1, 2, 3, 1, 2, 3. So if x is, one of the x-intercepts is positive 3.41. 3.41, let's just say, is about here. And x is 0.59, so close to 0.6. Just say it's about there. Our parabola will be passing through these two intercepts, just like that. Okay, so even though we have, I guess it looks more complicated in decimals, it's still giving us the exact same thing, and that is if there are any x-intercepts. Actually, there is one more question I want to do just quickly, and that is, sorry, what if we have a perfect square? Now, if you have a look at this, we know that this is saying x plus 2 bracket x plus 2. And has this already been factorized for us? Yes, it has. So we need to make each one equal 0. And you can see that we're going to end up with the same answer. So just to show you quickly, we'll have x plus 2 equals 0 for one of them. And the other one will also be x plus 2 equals 0. If we solve each one, we are going to get minus 2 on both sides, like we've normally done. We end up with x is equal to minus 2, and x down here will also equal minus 2. And why do you think we end up having two solutions, or two answers, or x-intercepts that are the same? Okay, so really, even though we have two we've gotten two of the same number and we can say there are two solutions, it's actually one solution, okay? Because they're the exact same thing. And what happens is, to understand why we get this, when we learn how to draw parabolas, so I'll quickly just draw one to show you so you have an idea. Okay, there's y and x. If x is equal to -2, just say -2 was here. And once again, x is also equal to -2, so the same point. This means whenever you have something like this, it's telling us our parabola, as we draw it, it just touches the line where x is equal to -2, so it just touches it and just intercepts it at this point. And that's why we have two solutions that are the same. This is what you end up with, a parabola that touches the x-axis just at a point, okay? So keep that in mind. Whenever you see something like this, it's telling you your parabola is just touching the x-axis and then continuing. And just to quickly recap, the different types of parabolas we can have when it comes to x-intercepts is this. We can have, I'll just draw 3, just to give you an idea to recap. We can have 2 x-intercepts. We can have 1 x-intercept, or where it just touches the graph, or 2 solutions that are the same, which is the example we did before, or we can have no x-intercepts. You can see how this parabola will never ever touch or cross the x-axis, okay? So they're the possible solutions or x-intercepts we can have. We can have 2 solutions, or 2 x-intercepts. We can have 1 solution, or we can have none, okay? And when we have none, this is where we cannot factorize anymore. Okay, so just keep that in mind. Thank you.